This is another great, difficult question on this section. I think there's a lot of really good stuff here where the strategies help us immensely and our instincts get us in trouble. If we look at this, one of our first instincts might be about the y-intercept, and we see that 1 there kind of attached at the end. But the reason that that instinct is bad is that the y-intercept stuff that we kind of know intuitively is all based on linear equations. Or quadratics, I guess, but questions where the x isn't an exponent. And so that's a problem here. This is an exponential. Things just don't behave the same way. Now, we could just avoid that instinct altogether by using one of our strategies here. We're being asked, how does this equation change, right? We have a whole equation, a whole curve here, and we're being asked to change the entire thing. But on the SAT, we don't really want to have to do that because it's complicated, our brains can't handle it that well, but we understand big changes by narrowing our focus to little changes, right? So what does happen in one point, that sets the tone, and that's the pattern that's probably going to help me in all sorts of points. And so because of the way these things are graphed, I do want to focus on those y-intercepts first, right? Because they seem to be different, right? I've got a little bit of a duplication here in D and B, but that's an easy point to think about because it's easy to see, but it's also easy to work with mathematically because the thing that's always true about a y-intercept is that the x is 0. So what we're going to do here is we're going to ignore the graphs for a second, and we are going to plug points into equations. I want to understand how this 1 point changes, the y-intercept, right? So I have to find out what is my original y-intercept, right? So that's going to be just about plugging in x is 0. So f of x, or f of 0, is 2 to the 0 plus 1. And this is where you can't make the assumption that 1 is going to be the y-intercept because exponentials behave differently. 2 to the 0 is 1. So the y-intercept is actually 2. So let me write it another way. The point 0, 2 is on the graph of f. So you wouldn't really see that just looking at the equation, but that's how exponentials work. So they're trying to trick you on that. But if we just plug in and we don't make an assumption, we prove the assumption, we can see that very obviously because everything raised to the 0 power is 1, and so very quickly the 2 kind of pops out. Now we're being given an instruction about what to do with that point, but technically with all the points, but we're really just focusing on this, is that y is equal to the negative of f of x. So if f of x is 2, then when we make this switch, the x will be the same, but the y is going to be negative. So 0, negative 2 should be a point. So now what I'm doing is I'm just looking at my graphs and I'm saying, well, which one has 0, negative 2 as a point? Not A, not B, that's 0, negative 1. C looks good, and D is 0, negative 1 as well. So why does it look like that? Why does the curve kind of keep going down to the right but kind of flattens out to the left? I don't know. I couldn't care less because this 1 point forces my hand. It makes me pick this choice. It's the only one that matches. And that's why plug points into equations is so helpful even when we kind of need to think about the entire equation. Is usually understanding what's happening at 1 point is sufficient to understand what's happening at every point. And the multiple choices really help us with that. So, if you have an equation and you're confused, a good rule of thumb is ask yourself, can I come up with some points? Can I think about this in a smaller, narrower terms and use the plug points and do equation strategy? So we made up the fact that we were using the y-intercept here. I could have picked something different. I could have picked x equals 1, but 0 generally is my go-to, and because I can see the y-intercepts very easily on all these graphs, that was what I wanted to look at, and sure enough, it was sufficient. So this question that looks like it's going to be really hard ends up being really easy because we narrowed our focus. So try to do that when you're feeling overwhelmed, and I promise a lot of stuff will look a lot easier.